This is the Borton Primary Magnet School in Tucson, Arizona.
Cuando queremos hacer un experimento, empezamos con una pregunta.
Kathy Lose is a bilingual second and third grade teacher at the school. Today's lesson combines mathematics and science, featuring balloons, string, and straws. Students will investigate how a balloon, when attached to a straw, will travel along a string. In a previous lesson, students were divided up into 8 groups, and each formulated a question they wanted to explore.
What is the amount of air pressure a balloon needs to travel 12 feet? Number 6, how far does the tiniest balloon go?
The students then made a hypothesis based on their questions.
Read it, please. It might go to 4 yards or more. So what you're going to do today is you are going to work with your team to work through your procedure to gather data. And what I mean is you're going to be getting information and you're going to be recording information that will help you prove or not prove your hypothesis. What are some things you're going to be needing to get? What are you going to be writing down today? Once you start with your balloon and you get them attached, what are some things you're going to need to record? Let's think real hard. ¿Qué tienen que escribir? ¿Qué tipo de información? I want everybody thinking for 30 seconds. I want to see lots of hands up. What do you think? Think about your question. Okay, hands up if you have an idea. What are you going to need to be writing down? Juan Carlos.
What you did.
What you did in, like what? Can you give me an example? Be more specific.
What you did to put the pieces together.
In your groups, just brainstorm very quickly in quiet conversation. What do you think you're going to need to be writing down? What kind of information? Okay, go.
The experiment.
Okay, about 5 more seconds.
The wall on the loft also, so it's not going to be touching the ground. So.
Okay, time's up. What are you going to write down? Juan Carlos.
How far did it go?
All right, so what do you have to do? What do you think you're going to have to do with the string?
Tape it in the wall and see.
Yeah, but what are you going to do with it though? How are you going to know how far it went?
By measuring.
By measuring. Okay, so some of you are going to need to do some measuring.
And so the first one is okay. Now we have to.
Is something that I feel is very, very important for children to use because it incorporates all different kinds of mathematics and it's just a real life experience.
We have to get that down.
Okay. But first, what angle are we going to put our string at? Every angle?
Actually, we're just going to put it at one angle. It's just going to be like, I think we
Diagonal?
Yeah.
What are you going to be writing here? Well, look, you have your question and your hypothesis and your materials. What's next? The procedure. So Lance, would you help that? Lizzie, maybe you could help him spell it because he usually writes in Spanish. You don't have to write it for him, but just tell him the letters. So you have, we put the straw on the string. And number 2? Andres, what was number 2?
We put the string up the roof.
All right, write that down, Lance. Okay, it sounds like, and remember, your data is going to go down here, and you have to be real specific. Don't just write numbers. And I see some. How are you going to measure your distance?
Well, we're gonna use like a ruler.
Okay, so someone maybe needs to go and get the ruler.
Or a
Okay.
I'll go get it.
All right.
What are we gonna do with the little thingy? Which one?
I'm sorry.
Do you want me to do that? Hold it from, no, not from there, from here. Or if not, it's gonna go out there. I went halfway. I went half through, Sean.
Okay, I need a ruler.
That says we cut the string and write it to the rock.
We have just finished a unit on probability and statistics, and the children were used to gathering information and they know that they need to have a fairly large sample to be pretty sure of their results.
Okay, let's see if it works now. Hey, that's too big. That's too big. That's way too big. We need small balloons, baby balloons. Okay.
Math and science are completely integrated together because you can't do one without the other. And you have to have experiences in collecting data and knowing what is good data, and being able to take a lot of information that you collect through either graphing, through charting, through comparing, contrasting, and recording, and being able to take a look at it and then forming your opinions.
2 feet and 3 inches.
How are you going to tell the time? Okay, and which hand? What are you counting?
The red one.
When the red hand is what?
Seconds.
Seconds.
No, at least not from here.
That's another measure.
Actually, this is time. I know. I'm measuring.
I need you all to come to the floor now with the information you had. I know you're not done. We're going to keep going tomorrow. But I want to talk about a few things about data. We had thought of distance and what word? Remember that big word? Volume. We added another type of measurement. What was that? Time. Jason, how come your group had to measure time?
Because on ours, on our question, it says is a large round balloon or a large hot dog balloon faster on each string, and we had to use time for the counting part.
Okay, so he measured time. And how did you count them? In what unit, Pablo?
Seconds.
Can you tell us where you had to sit so you could see the clock?
In the left.
You sat on the left. And so look here. In volume, this group, Graciela, what did you measure? ¿Te recuerdas?
Well, we measured in air puffs.
Air puffs. Okay. Because now, let's look up here with data. When people started, this is what I saw. Some person say,
No.
about so high. No? What's wrong with this data?
It doesn't have enough information.
Okay, what did you, when you are measuring, when you are recording data, what's important?
To write more information.
Okay, could you, this group, Lance, really quickly, could you give me one piece of data you wrote that has a measurement in it?
The yellow balloon went 1 inch.
Okay, look, that's data. Okay, who else has a piece of data they can share?
Un globo azul con 3 segundos.
Okay, globo azul 3 segundos. Okay, that has a measurement. Juan Carlos, give me a piece of data.
One went 2 feet.
Okay.
Launch 1.
Okay, launch 1 went 2 feet.
2 feet 10 inches.
Okay, okay. Any scientific investigation in anything involves collecting data, and collecting data involves either measurement, involves number, involves statistics, involves even probability. You know, how many times something is likely to happen. Can you replicate, can you repeat your results? And so I really see that within science, you know, math and science are completely integrated together because you can't do one without the other.
What are the mathematical skills and concepts embedded in this lesson? What are some strategies for assessing conceptual understanding during the lesson? Consider the role of teacher intervention as students develop measurement skills.